Good evening, I am Mr. Ish. Thank you for joining me for this circle problems number 5 video. Circles are huge. No matter what type of exam or test you're looking at, there's always some question or two on circles. We have a question here, an interesting one. If the radius of a circle is doubled, by what factor is the sector area changed for a given value, theta value? And you know we're talking here about angle, but in radians. We're talking about a certain radius. At this given radius, the area of a circle is always equal to pi r square. At the same radius, what is the value of a sector area? Half r square theta. We don't have to worry too much about this. This is just more to distract you than anything. Anything that you're really worried about is this right here, the radius. This everything here represents with regards to the original dimensions for a given radius. For the new radius, the radius is doubled, so now it becomes 2r. What does the area become? Well, you're going to put 2r in place of radius, and you're going to square that because it's always pi r square. You get 4 pi r square. And what about the area of a sector? We can just put like a little s over here to denote that this is area of a sector. Here you're looking at half, but you know the radius might as well just be 2r because that's what we're looking at, theta. What do we get? 4r square over 2, which is 2r square theta. Now look at everything here, what we're asking. By what factor is the sector area changed for a given value? Well, since we're talking about sector areas, you might as well compare the old and the new. By what factor? You're going to do like a product answer. We'll take the new area, right? The new area 2r squared theta, and we'll divide it by the old area of a sector, which is r squared theta over 2. When you do this computation, this 2 multiplies here with the numerator. You get 4r squared theta divided by r squared theta. The r squared and the theta cancels out, and we get an answer of 4. When the radius of the circle is doubled, the area of a sector for a given theta value or angle radian value is increased, not by in terms of sum, is increased by a product of 4. So you can say that the area of the sector is 4 times that of the original area of the sector, and that completes this question over here. This is our second and last question of this video, and I promise you a challenging question over here. We have to find the equation of line A. This is my line A right here. If it goes through the center of the circle, which has a coordinate axis value of -3, 3, and it is perpendicular to line B, which is a tangent line, and that tangent line has the equation y is equal to 3 over 2x. How could you demonstrate this on an xy plane? You don't have to, but just for visualizing it, you have a center of the circle -3, 3. Y equals 3 over 2x is a steep line going to the center of the origin, as you can imagine. You have a tangent over here, so you have a circle which must be coming like this. Of course, I haven't really drawn it too well, but you would have a tangent going right over here. You have a line A which would be going right here, and it is perpendicular to this line over here. This is my line A, this is line B. There's an important property which you should know, and I've kind of given it to you over here, and it is this right here, perpendicular. At any point you have a circle and you draw a line tangent to that circle, right? You know what a tangent line is, a line which grazes a curve at only one point. This is a tangent line at this point. This is a tangent line at this point right here. This is a tangent line here at this point. At any point you have a line tangent to a circle. At any point on that circle, you look from the center and you draw a radius to that line. It'll always be 90 degrees to that tangent line. If you draw from the center over here and you draw a radius to that tangent line, it'll be 90 degrees. Likewise, this is 90 degrees. This line which I'm drawing here as a radius is no different than this line A in this example that we're looking at, line A. It's part of this line A from here to here is a radius, therefore it must be perpendicular to this tangent line right here. So keep that property in mind. A line which is tangent to a circle, when connected by the radius, that tangent line and the radius are at a relationship of 90 degrees. What do we know about the slope of y equals 3 over 2x? This right here is the slope. We have a slope which is m is equal to 3 over 2. A line which is perpendicular to it must have a negative reciprocal of that value, -2 over 3. That's a property you should know. m1 is equal to -1 over m2. A line and its perpendicular have a negative reciprocal relationship. Therefore, line A, which is perpendicular now to line B, must have a slope of -2 over 3. Y is equal to -2 over 3x plus b. and line A goes to this point right here, center. We can plug these as x and my y values right here. 3 is equal to minus 2 over 3 times minus 3 plus b. This minus and this minus cancel out, this 3 cancel out. I have 3 is equal to 2 plus b is equal to 3 minus 2, which is 1. Therefore, the equation of line A must be y is equal to minus 2 over 3x plus 1. This minus 2 over 3 here accounts for the fact that we have a slope which is a perpendicular to a line B, a negative reciprocal of this, and this plus 1 accounts for the fact that we plugged in these x and y values and we calculated and we found a new y-intercept. We now have our equation of line A. So keep in mind, equation of line B was y is equal to 3 over 2x. Its slope was equal to 3 over 2. We had to find this negative reciprocal of that line A, which was minus 2 over 3. We plugged in these values minus 3 comma 3, and we were able to find the equation of line A. And the most important property you had to know was that the line tangent to your circle going through the radius, which happened to be line A, should be perpendicular. Therefore, we had to do this negative reciprocal. With that, we'll end this question. Thank you for watching. Have a nice day.